Today we're going to introduce you to a topic called conversions. It's simply a process to describe how much of something you have with different units. For instance, I'm 5 foot 8 inches tall, but I'm also 172.7 centimeters tall, and I happen to be just a little over 1.7 meters tall. My height's not changing, I'm just measuring my height in different units. Originally inches and feet, then centimeters and meters. You'll need to use conversions in many places in your life, both in your academic career, like in the sciences, physics, chemistry, biology, and other sciences. In medicine, it's used all the time. Cooking, it's so very important. And construction, maintenance, and repair are just few of the places that you might need to use conversions moving down the road. So, most of us are comfortable with the idea that there's 100 cents in a dollar. Well, my question for you is, if you have $2, how many cents do you have? Well, if we have $2, to find out how many cents you have, you can set up a fraction and say there are 100 cents in a dollar. Notice the top and the bottom of the fraction are worth the same amount. 100 cents and $1 are the same thing. To keep things nice and smooth and balanced, we're going to put that original value over 1. Then we can do some math. 2 times 100 equals 200. Divided by 1 is still 200. So 200 is the sum of this. But look how the units work out. We have dollars on the top and the bottom, so they divide out, leaving us with units of just cents. And this says that 200 cents is the exact same amount as $200. So the secret to doing this is remembering what happens when you multiply things by 1. So consider these problems. What's 3 times 1? 3. What's 17 times 1? Yeah, 17. 256 times 1? 256, and what's that general pattern? Any number times itself is equal to 1. What about when you divide a number by itself? What's 4 divided by 4? It's 1. 21 divided by 1? 1. 243 divided by 243? 1. So anytime you divide a number by itself, it's still equal to 1. So what if you set up a problem like this? 8 times 5 divided by 5. Since we know 5 divided by 5 is the same thing as 1, this problem is the same as 8 times 1, and the answer is just 8. So what if you had 37 times 73 divided by 73? What's that answer going to be? You're right, you could simplify that, the 73 divided by 73, and then you have 37 divided by, or times 1, which is just 37. Well, we've seen some problems with some units already this year. So let's take a look at this average velocity problem. We've got average velocity as change in position divided by change in time. We have 8 meters divided by 2 seconds. Now we know that 8 divided by 2 is 4, and meters divided by seconds are meters per second. So in this case, because we have 2 different units here, we have to keep those units in there. Meters divided by seconds ends up meters per second. However, what if you had something like this? 6 blue cars divided by 6 blue cars. Now you know that 6 divided by 2 is 3, but what about blue cars divided by blue cars? Just like numbers, we have to carry out how the units would divide out. And you know that anything divided by itself cancels out or equals 1, so this answer actually becomes 3 and no units go with it because the units themselves canceled out. So ultimately what we're saying here is if you give a certain amount of anything, if you multiply it by 1 in a variety of ways, you end up with the same amount of the thing you started with, but the units might look a little different. I've put some equivalents up on the top here. Equivalents are just 2 things that are the same length, the same size, the same mass, whatever. These happen to be lengths. We know that 12 inches and 1 foot are the same length, and there are 3 feet in 1 yard. We also know that there's 1,700 yards, 1,760 yards in 1 mile. So if we follow a set of steps. Planning a conversion path, writing original value with units over 1, and follow these steps. We can convert anything from inches to feet to yards to miles or back and forth. So let's try one problem. 7 yards into inches. The first thing we're supposed to do is plan a conversion path. Can we go straight from yards to inches? Nope, we can go from yards to feet and then from feet to inches. So we're going to go from yards to feet. We can use this one for that. And then we can use the far left-hand equivalent to go from feet to inches. So next up, we're supposed to write the original values with units over 1. So the original value in units is 7 yards, and we're going to set that up with a fraction over 1. Next up, we're going to build a skeleton with units. Now, because there were 3 parts to our plan, there's going to be 3 fractions in our problem. Next up, we're going to include the units in there. Now, the way the units are going to work out, whatever units you start with, you have to get rid of them in the next step to transfer them to the next unit, to the next unit. So we had yards on the top here. To get rid of the yards on the top, we're going to put yards in the bottom. And it says up here in our plan, we're going to go from yards to feet. So we put feet on the top. But we don't really want our answer to be in feet. We want to go to inches. So to get rid of feet, we're going to put feet on the bottom. And to go to inches, the inches go on the top. Now what we've done here is set this up so the yards will cancel out, the feet will cancel out, and our answer will end up in inches. So we put in the original values or the equivalent values from the top. It says up top there are 3 feet and a yard. 3 feet and 1 yard is the same distance. That's a fancy way to multiply by 1. There are 12 inches in a foot. Again, that's a fancy way to multiply by 1. So really, we have 7 yards and we're multiplying it by 1 2 different ways. However, because the values in units in here are a little different, we've got yards will cancel each other out here, feet will cancel each other out, feet divided by feet cancel out. But let's take a look at the numbers. 7 times 3 times 12. We'll multiply all those because they're on the top part of the fraction. And that equals 252. Now, if we divided by 1 and divided by 1 and divided by 1, that would still be 252. So the answer is 252, and the units that we left off with are inches. Now, what's longer, 252 inches or 7 yards? The answer is they're the same. They are equivalents to one another. What about if we went from inches to yards? So we start with a smaller value, go to a bigger one. We'll start with our plan, inches to feet to yards. We'll put our original value over 1, 72 inches. Over 1, we build our skeleton. We've got 1, 2, 3 steps in our plan. So we build our skeleton. We have to get rid of inches, so we're going to put those in the denominator and the base or in the basement. We'll go to feet, get rid of feet, put those on the bottom, and we'll go to yards. We plug in values that are equivalents. There are 12 inches in a foot. There are 3 feet in 1 yard. And now we have to multiply through. We need to multiply through. 72 times 1 is 72. Divided by 12 would be 6. Divided by 3 would be 2. And let's see how the units work out. Inches cancel out, feet cancel out. Answer is 2 yards. So, there's some quick problems for you. You might want to try these on your own. This would be a good problem. 1.8 yards into inches, or 31,680 inches into miles. You can pause the video at this time and do these on your own, and then you can come back and check your answers. So up here, we're going to go from yards to feet to inches. 1.8 yards over 1. Yards to feet, get rid of feet, and go to inches. Put in the equivalent values in there. We know there are 3 feet in a yard and 12 feet in an inch. And 1.8 yards looks like it equals 64.8 inches. The units cancel out, yards to feet to inches. So that would be about the average height of a freshman. 5 foot 4 inches and some change. How about down here with this 31,600 inches? We're going to have to go from inches to feet to yards to miles to So that's 4 fractions along the way, 31,680 inches. And again, we want to put that over 1. We build our skeleton. We need 4 fractions this time, 1, 2, 3, 4 in the plan. Get rid of inches, go to feet, get rid of feet, go to yards, get rid of yards, go to miles. We plug in our values. There's 12 inches in a foot. There are 3 feet in a yard, 1,760 yards in a mile. We'd multiply across the top, divide across the bottom. So what we punch into the calculator is 31,680 inches divided by 12, divided by 3, divided by 1760, and that would equal 0.5. And the units that work out, inches cancel out, feet cancel out, yards cancel out, and our answer is miles. So evidently, 31,680 inches equals 0.5 miles, or 1/2 mile. I hope that helps.